Here we get to conditional equivalencies. Remember all of the different equations that, hey, this is going to end up being the same as this and this the same as this. That's all coming to a head now. The first one's actually really simple. And that is that you and I discovered that basically these two items that we have right here are equivalent by the truth table values that you and I went over before. Now, why does that matter? Well, because in reality, when we do our truth values, we really don't want the implication part. We really want to get rid of it and frankly replace it with conjunctions that you and I are used to and frankly can solve pretty quickly, but also it's going to match other properties down the road that we can again shrink a larger equation down to a much more manageable size. So that not P or Q is easier to work with than we had some implications and will be easier with much more compound equations as well. So when we're done, we're going to be left with just the ands and ors and negation. I should have that in there too. That's what we're going to end up with if you're given an equation that has an implication in it. Now, that's called CDE for short, or conditional disjunction equivalence, where again, all I'm doing is replacing an equation that has this with this. And that's about it. Because remember, they both come up to be exact same values anyway. So that'll show us and help us a little bit longer down the road when it comes to solving things. But let's show you some more. So here's where things get a little bit more interesting, is our other conditional equivalencies. These are going to have names eventually, by the way, but notice there's a significant portion of these. So if you were to basically, and we're going to have an exercise here in a minute, these two, if we were to do a long truth table value set with them, they're going to end up being exactly equivalent to one another. Remember that P implies Q is a form. P and Q are simple variables. We could have compound assignments or compound statements within P and Q. So think of that P implies Q as a form. P can be much more complicated and Q can be much more complicated. Here's a perfect example. Here is A and B implies A or B. Now, right now, what you're looking at is you're kind of looking at this table right here, which actually the first part is very familiar. And you're trying to figure out, well, wait a minute, I can't solve that because none of that actually fits any of these forms, what I wanted to later. That's actually not true, because we can do simple substitution to make it then fit one of these items that are in here. So if we were to replace that A and B with a P, and the A or B with a Q, you would actually end up with a P implies Q. Now, we got to throw A and B back in there, so bear with me here. But that now, you have that in that form. And all we do is simple substitution. So notice we're going to be doing some simple substitution just to get it to fit one of these so it makes our lives easier in the long run. Now, all of these that you see right here have been proven to basically match one another. You and I just did one. Now, I take it back. There's a few others that we've actually done before in the previous set of notes. I just didn't tell you about it yet. So we're going to do that here in a second. Your other one is some biconditional equivalencies. If you happen to know that you have a biconditional equivalency, great. There's some other features on that. But again, there's some of these that'll help you get rid of our implication, and then some of them that don't. So just a heads up, there is a mixed bag with this. But again, the important part, and I'll go over this again, is you got to do some simple substitution to get it into some form that looks like this in order for us to do some, well, reduction of equations. So the next part is I want you to pick, other than this first one here that we've done, ad nauseum now, I want you to pick another one, any one of the ones that we have here, and I want you to do the long version of this, which is the truth table. So notice that's not truth value, that's truth table. And prove that, frankly, they match up. Pick one of them, because it might be a test question, by the way. So prove that they equal one another. And that's all I want for right now, and we'll go over some solutions here in a little bit.